Okay, so red elk runs at a speed of 9.2 meters per second horizontally off a cliff that is 6.4 meters above the water. So that 6.4 is this distance here, okay? And then the 9.2 meters per second, that's how fast he's going to the side, right? So I think you know this and this. You always know this in these problems. You always know that. We always know this. And then this is something that's given to you, right? And this is something that's given to you, okay? So just pause for a moment. See if you can fill in those blanks, right? Because that's the first step. Okay, so the 9.2 goes here. This is 0. There's no acceleration horizontally. There is vertically, but not horizontally. This is negative 9.8. That 6.4, we make that negative 6.4 because he starts here, but he ends down here, right? He's going to go, so vertically he goes down 6.4. And then the initial velocity is 0 like that, okay? So let's figure out everything about this. Let's start on this side, on the vertical side. Okay, so for vertical, I'm going to use Vf squared equals Vi squared plus 2ax, right? So the final velocity is going to be the square root of, what, 0 squared plus 2 times negative 9.8 times negative 6.4. Okay, so hold on. Square root of 2 times 6.4 times 9.8. That is exactly 11.2. Now, of course, it's going to be positive, but I better make it negative. So negative 11.2 meters per second, right? It's negative because it goes down. This formula can't give us a negative, right? Okay. And then let's find the time. I'm going to use x is VIT plus 1/2 AT squared. So let's see, negative 6.4 equals, the initial velocity is 0, so that whole term goes away. So it's 1/2 negative 9.8 t squared, right? Okay, so the first thing I'm going to do is I'm going to type negative 6.4. I'm going to go times 2. I'm going to divide by negative 9.8. And by the way, you could just leave both negatives out if you're like, strapped for time like I am here. Okay, and now I've got 1.306 is equal to, and that's t squared, right? To get the answer, I'm going to go second square root. Second answer. And I get 1.143, I'll say. T is 1.143 seconds, right? You want to carry some extra digits, and really I should be saying 1.4. It's really 1.142857, but at least carry one extra digit, okay, at the very least. Now remember, time goes across. It's the only thing that's shared. It's the same, right? And now I can figure out x, right? And so now we are on the horizontal side, right? Okay, and really this is just x is vt. Right, so that's going to be 9.2 times 1.143. So literally I'm going to go times 9.2 and I'll get that answer, 10.51. Right? Okay, so let's answer the questions in the boxes. What time is in the air? Well, that's the time, right? 1.14 seconds. Right? C, what is his final impact velocity with the water? Right? It says vertical velocity, and that's it. So be careful to make it negative, right? The vertical velocity. So that's C, right? This is B, the answer to B. D says, how far from the base of the cliff does he hit the water? Whoops. 10.5 meters, right? That would be D, right? And then E and F, I got to erase to get the answer to E and F, okay, because I need the space to draw it. So let's answer E and F here. Are you ready? I'm erasing. Boom. Okay, so we got our final velocity here was negative 11.2. This final velocity was 9.2. So let's draw a picture of that over. And then remember the y component comes right from the nose of it, right? So we've got an angle. We need to find an angle and a magnitude. So this is 9.2, 11.2. So that angle is tan minus 1 You have to do the inverse tan of 11.2 over 9.2. All right. Second tan 11.2 divided by this angle is going to be bigger than 45 degrees. It's 50.6 degrees. Right? So 50.6 degrees. Notice I've shown which angle I'm talking about by putting a little arc there. I've labeled it with degrees, right? And then this is, by the way, the speed. Okay, so the speed is the magnitude of this velocity vector. It's just the square root of 9.2 squared plus 11.2 squared. Let's try it. Square root of 9.2 squared. And if one of these components is negative, remember, don't put the negative in, or your calculator will explode. Really, seriously, like sparks, flames, for real. Okay, 14.5 meters per second. Either that or it'll calculate an answer that's wrong. Okay, so 14.5 meters per second. This is a beautiful vector. I've labeled which way it's going with arrows. I've labeled which angle I'm using. I've labeled the hypotenuse. I've labeled that angle. I'm going to get all the points for that.